absent from class from the first part of class when I had a technology snafu, you're going to have to get the notes from somebody else. But for those of you who are live and actually have the notes, I'm just going to scroll down to the bottom, and I want to give you just a couple of things. Okay, I just want to give you a couple of things. First of all, momentum is conserved in all collisions. Now, this will help us because we're going to be evaluating the situation and we're going to be deriving a momentum equation. Yes? Yeah, we're going to talk about that tomorrow. We're going to... So this is for all collisions. So momentum is conserved. What's not going to be conserved is kinetic energy. And we're going to talk about that. But in all collisions, the momentum is conserved. All types. Okay? Now, I know that when I had you do your notes a while ago from the physics classroom, that they actually had an example for momentum in explosions. And so what you have to do when you think about an explosion is that you actually have a mass and a velocity to begin with, and then of course the explosion occurs and all the particles fly away in different directions at different velocities with different masses. And so but even in explosions, the momentum is conserved. So momentum is conserved in explosions. Okay? And just for you hockey players in particular, momentum is also conserved when objects push off each other. Okay? So I know I've seen enough hockey games to see that, you're kind of pushing at each other. And believe it or not, momentum is going to be conserved in that interaction. And so we actually, for the AB example that I gave you earlier with the two balls, we could develop, this is a conservation of momentum equation. Okay, so what we're going to do is we're going to look at each situation and we're going to draw a before and after picture like we started our notes today. And so if we were looking at those two balls, we're going to have the mass of A times the initial velocity of A plus the mass of B times the initial velocity of B is equal to the mass of A times the velocity final of A plus the mass of B times the velocity final for B. Okay, so what you're doing is you're just writing individual little momentum equations for each object. And so the left side is the before, so this is our before picture. Okay, and this is our after picture. Before and after. All right. And so, believe it or not, this happens in all kinds of settings. Just like yesterday, I talked to you about stopping distance and stopping time and how that's really applicable. Well, I will just say, after you learn a little about this, none of your interactions will ever seem like they are the same. So, here we go. Let's go to the first problem. Sample problem 6D. And it says, we have a 75 kilogram boater initially at rest in a stationary 45 kilogram boat. So that's my before. So my before picture, and as you know, I am not the best artist in the world, so this is literally what it looks like in my notes. There's my boat. Okay. There's my person. Thank you. Okay. So, okay. So, mass of the person, 75 kilograms. Initial velocity of the person is, you tell me. Initial velocity of the person is, you tell me, 0 meters per second. Okay, the mass of the boat, you've got it in your packet. Tell me what it's, yeah, 45 kilograms. And the initial velocity of the boat. Okay, what's the initial velocity of the boat? 0, because it's stationary. Okay, that's my before. My after picture says, if the boater moves out of the boat with a velocity of 2.5 meters per second to the right, so now I'm just thinking about this. If the person is jumping this direction, so here's my person stepping out to the right, what is the boat going to want to naturally do? I'm sure you've all climbed out of a boat before. What does it want to do? Yeah, so this is probably, I'm going to make a prediction, it's going to end up going to the left. Yes? Now, velocity final of the person is 2.5 meters per second, and the mass of the person is still 75 kilograms. And then the mass of the boat is still 45 kilograms. Okay. So I literally want you to practice this. So on the left-hand side, mass of the person times the velocity initial of the person plus the mass of the boater, of the boat, sorry, times the initial velocity of the boat, right? That's what I would get from the information I'm given. This is equal to the mass of the boat times the velocity final of the boat plus the mass of the person times the velocity final of the person. Okay, so now when you say, I heard you say it, what'd you say? Okay, I'm not going there yet. Okay, so remember in physics when we can let things go to 0, we do, but we show that we're doing that. So you don't just magically put a 0 here. Okay, now what am I trying to find? What don't I have? No, seriously, what do I not have? Right. Okay, so that's what I want. So, I actually want to see you leave it as a variable expression. Now I'm going to say this again. I want you to leave it as a variable expression until you get it completely rearranged, because you will miss a sign. And your answers will be completely off the wall. So, because I've taught this for a million years. Okay, not quite a million years, but I've taught this a lot. Most common mistake ever, and it happens about 1 in 3. Okay, so let's rearrange that equation. Let's rearrange that equation to solve for f of b. So what do I need to do first? Yeah, so I'm going to subtract an MP VFP on both sides. So I'm going to end up with a minus MP VFP over here. Okay, so that's gone. What do I need to do next? Divide by mass of the boat, and then I'm going to be left with this. Now, once you have it like this for every problem, please feel free to substitute in. Be careful with respect to the signs. That's all I'm going to tell you. So go ahead and solve it and reconcile your units and tell me what you end up with. Okay, so what does this end up being? How many sig figs should we have? 2. Yep, I'm just checking. So, negative, what'd you get? Negative 4.2 meters per second. Left. Okay? Negative 4.2. Okay, I have 3 for you to practice on a separate sheet of paper. Due tomorrow, por favor. The first one may look familiar to you if you remember the final from first semester.